Happy last day of week 2. We are getting ready for tomorrow, which is day 10, and we are continuing our focus on probability as we have the past couple of days. So we are now going to be talking about probability and combinations. And this is kind of a little bit of a difficult thing to think through for some students. Oftentimes by the time we get to, the third or so day of probability, it's kind of hard to keep track of all the different methods. So I do want to stress that we are going through a very, very big topic very briefly, right? We're only focusing on it for, part of a week. So it's completely okay to feel like you're not 100% perfect on which strategy to use when. I think being able to tell that comes with time and with practice. So tomorrow, as we do practice together, make sure that you're asking questions, you're helping each other, you're explaining things in different ways as we try and gain a better foundation of what strategies to use when. So probability problems often require careful counting of combinations. In the case where objects are grouped, and this is kind of like your what to look for. It is often easiest to divide the number of ways to form a group using the given restrictions by the total number of groups that could be formed without a restriction. Using the given restrictions by the total number of groups that can be formed without the restrictions. The 26 letters of the alphabet are placed on tiles and randomly separated into 2 equal piles. What is the probability that the word math could be found in one of the 2 piles? And some of the markers for how you know that combinations are useful in this is that you are told that there's just 2 piles of tiles. And obviously with something like this, there isn't exactly an order with putting the tiles into the piles, right? So anytime you have something like this, something that feels like it's a little bit too cumbersome to really try and do the traditional way, like, multiplying fractions representing probabilities, like what are the chances I get the letter M, then the letter A, right? Something like that is assuming there's an order. This is just saying you have a big handful of tiles that are split. What are your chances? So here are some steps, and I've kind of laid it out a little bit more scaffolded so that we can walk through it slowly. We first find the number of ways to choose 13 letters out of 26. That's going to be your denominator of your fraction. On the bottom, we want to put our total possible outcomes, and then on the top, the outcome that we specifically want. So the number of ways to choose 13 letters out of a group of 26, we're going to do 26 choose 13, right? You probably were figuring that would be what to do, right? Not overthinking it. On the top, we want to find the number of ways to choose math, as well as 9 other letters. So let's think through that. Okay. We have the 4 letters of math, right? So let's kind of put it into 2 groups. These are the letters that spell math, and this is everything else. So oftentimes with these grouping problems, you want to think about your groups as the things that you want and the things that you don't, and that will help you figure out the smaller groups to separate to on the top. So on our top, I'm going to walk you guys through this a little bit more, and then in the second example, you can try it out on your own. I'll give you some time to think through it. On the top, we're going to say, okay, we have the 4 letters of math. I want to choose all 4. And then I also want to multiply that because I want 2 things to happen. I want all 4 letters of math, and I want the 22 other things, right? Because we have our 26, typically the 4 that we want. That's 22 that we don't want. And we're going to choose 9 of them because we want how many ways to choose math, as well as just 9 other letters, not specific. We don't need any, specific letters from that other group. And I want to point out something that has helped my students in the past with their understanding. Notice how these numbers connect as well as how these numbers connect. This is kind of the way that I look to double check my work, I look to see that my total on the bottom, the total of 26, matches with combining my totals on the top. And your totals on the top, you can have, one thing on the top. Sometimes we might have 2 or 3 things going on depending on the complexity of the problem. And then on the bottom, we have the 13. That's the tiles that we are choosing, right? So on the top, we also need to be choosing a total of 13 tiles. And that's coming from 2 distinct places in this case, okay? So I just wanted to point that out here just to make it clear. And the interesting thing just to point out is when I do 4 choose 4, remember that's 4 factorial over, and then we have what we're choosing, 4 factorial, times the 4 minus 4. It looks a little funny, factorial. And so we have 4 factorial over 4 factorial times 0 factorial. Remember 0 factorial is 1 if you try it on your calculator. It's a little bit weird to think about. And we want to do math, probability. It's a little bit weird, but it is 1. So this ends up being the same thing on top and the bottom, which means it does simplify to 1. So that is always 1. Anytime you have the same number, like a 4 and a 4 for combination, you always do get a 1. Because if you have 4 things and you want to choose those 4, there's only really one way that that can happen, is kind of how I think about it logically. So I just wanted to point that out. So this fraction will simplify to 11 over 230 if you calculate that using your combinations on your calculator. But there is one small caveat that I want to point out, and that caveat comes from this statement here, which says, note, it could be in either of the 2 piles. Because remember, we're putting all our tiles into 2 piles, and we're asking what are the chances that either of the piles have the letters that spell out math. So we want to think about the fact that we are assuming that 11 out of 230 are the chances it is in one pile, right? There's 11 out of 230 that it's here, 11 out of 230 that it's here. Since there are 2 possible piles that it could happen, we're going to do that times 2. And so our total is going to be 22 over 230, which will simplify to 11 over 115. Because remember, when you multiply by 2, it's like 2 over 1, so only the numerator is getting multiplied by 2. And a lot of these problems do have that caveat that you do have like multiple different groups that it could happen with. So you want to be keeping a lookout for that kind of vocabulary. So let's go to our second example. I believe this is the only other example. Yep. I wanted to make it pretty straightforward, so there's only 2 examples so you don't get overwhelmed. Now, example 2 says 5 boys and 7 girls are randomly assigned to 3 groups. So let's just kind of highlight important information. Total boys, total girls, 3 groups of 4 students. So there's 1, 2, 3 groups of 4 students. Just to kind of give you a visual. What are the chances that one of the 3 groups is all girls? Okay, so something you could think of here is you could make a note to triple at the end, right? Because there are 3 chances that you have for all girls. So what I want you to think through is, I've got kind of a little bit of laid out steps here. I want you to think through the problem. I want you to try your best and work through it, put what you've got, and then unpause the video when you're ready to compare and contrast with how I set it up. Okay, so here is my laid out work. I've put on the bottom, and I kind of try to highlight it to color code, the 12 choose 4, because we have 12 total students, the 7 girls and the 5 boys added together. And I want to choose a group of 4. And then I want to choose none of the boys, so I did 5 choose none, and I want 4 of the 7 girls. So I do want to point out one more time just how the 5, the 7 makes the 12. Oh, you can't see that at all. Makes your 12 here. I'll just underline that to make it a little bit easier to see. And then also how the 0 and the 4 makes the 4. Just to point out a quick note is that 5 choose 0, if you look at the last thing I put on my calculator, does create a 1. And if you think through why that is, if you do 5 choose 0, you do 5 factorial on the top. Remember, you do 0 factorial on the bottom, and then 5 minus 0 factorial. Remember, 0 factorial we said on the calculator was 1. So it does turn out to be 1 times 5 factorial on the bottom, which is the same thing as 5 factorial. You got the same thing on the top and bottom, that is a 1. And the way to think about that is, if there are 5 things, the ways that you can choose none, it's one way, you don't do anything. So some people don't include this piece, the 5 choose 0. I like to include it just to have that cohesive look to the problem, so I can see the 5, 7, and the 12 and all that kind of stuff. So you can include it, you don't have to, because it does simplify to 1. Okay, so the next page on 132, these are practice problems that we're going to do tomorrow. What you're going to do is you're going to move for the next video. We're going to be moving to our complementary counting. So we're going to do another kind of mini topic. It begins on page 134 of our week 2 course packet. Okay, so I'll see you guys in the next video.